Hi, I'm Rosie Sargent from the Wood and Fibre team at Scion, and today I'm presenting about some work we've been doing in the thermal modification area. So thermal modification is a process where we heat the wood to high temperatures in the absence of oxygen, and this prevents the wood from burning during the process. And this changes the chemistry of the wood cell walls itself without having to add any chemicals or anything else to the wood. So down bottom right here, we've got a little diagram of, simplified diagram of the polymers in the wood cell wall. Hemicelluloses have these hydroxyl groups on them which bond to water, and the thermal modification process removes some of those hydroxyl groups so we get less water associated with the wood. And this has a number of changes to the properties of the wood. So with severe modifications, it increases the durability of the wood and it increases the dimensional stability, which means that the wood shrinks and swells less in response to changes in moisture content. It also darkens the wood colour, as you can see from the picture here, and for severe modifications, it can reduce the strength of the timber as well. So thermal modification has been commercialised around the world for quite a large number of wood species. In New Zealand, radiata pine, thermally modified radiata pine cladding is sold. So we are now looking at other New Zealand grown species that we could thermally modify with the aim of increasing the sapwood durability, but also boosting the durability of the heartwood of species that already have a little bit of durability in the heartwood. So for this, we chose Douglas fir and Cypressus lusitanica. So here is what the two species look like before they have been modified. And then we modified them at 220 degrees. As you can see, they've gone quite a lot darker. And then for the Douglas fir, we did an even higher temperature, which is darker again. And these sort of temperatures are similar to what the commercially produced radiata pine is in New Zealand. So the primary property we are looking for here is improved durability. So in New Zealand, a product like, say, a deck has a minimum service life of 15 years, but we don't want to have to wait 15 years to see whether a modification worked or not. So we have a range of durability tests that we can do, accelerated tests, starting with a lab test where you use very controlled conditions. You can get a result in a matter of months, but it only gives you a very broad indication of whether you've got increases in durability or not. Then going on to Fungicella stakelets. So this is where we have a warmed bed of soil and we have like little ice block sticks from each wood type, and this runs for a number of years, typically around 3 years. And then you go on to outdoor durability tests, which better mimic in-service conditions. So this is like mimicking a cladding application, but it's more severe than you would get in cladding in a house, so you can get a result in, say, 7 years. And at the moment, we are about halfway through the Fungicella stakelet testing for these two species. So for the Fungicella stakelets, for each wood type, we have roughly 10 samples, and every 3 months they will get removed from the soil and they get assessed for their condition. So a condition of 10 means that they look absolutely perfect, and a condition of 0 means that they've rotted away completely. So the lines here, each point is the average condition for each of those 10 stakelets, and then the error bars show one standard error. So there's actually quite a lot of variation in condition between stakelets within the same wood type. So the light blue line here, light blue lines here, is the unmodified Douglas fir. This is the condition is dropping off relatively rapidly. That's not surprising. Douglas fir heartwood does have a bit of durability, but not a lot. So it's not really a surprising result that it's performing similarly to the sapwood. The darker blue lines are the modified Douglas fir, and you can see that there's a big increase in the condition of the stakelets, showing that we likely have an increase in durability We also have a number of control samples that we include in these tests of materials that we have a good idea of how they're going to behave. So at the top line, we've got CCA treated radiated pine. We expect this to perform well above the minimum required for decking in New Zealand, say, so we'd expect that to have a very high condition and do well. We have Tōtara heartwood. Tōtara is a class 1 naturally durable species. That's the highest durability class, so again we would expect that to be performing very well in this test. And then we have thermally modified radiated pine, which has been approved for use as a cladding product. And we would expect that to be towards the lower end of the minimum requirements for outdoor use in New Zealand. So both the thermally modified Douglas fir heartwood and sapwood are not significantly different to the thermally modified radiata and the Tōtara. And the thermally modified sapwood is not significantly different to the CCA treated radiated pine as well. So this is a good result, shows we're getting broadly similar behaviour between our thermally modified samples and the controls, so it is worthwhile going on to downstream testing. And then again for the Lusitanica, the sapwood, the pink dotted line, unmodified, that drops off relatively quickly, which is not surprising. The sapwood isn't durable. The heartwood, solid pink line, is all of the stakelets are in a better condition. That's not surprising. Lusitanica is in the upper end of class 3 natural durability, so it has a degree of natural durability. And then after the modification, the red lines, you can see both the heartwood and the sapwood. There's this really big jump in the condition of the stakelets. So, and they are not significantly different in condition to all of our controls. So that's a really good result, and that's a really strong indication that they're performing similarly to these other materials, and it's worth going on to longer term testing. So where to next for this? The Fungicella stakelet tests, we're going to continue testing until all of the stakelets have failed. So for some of those more durable samples, that might be quite a long time. And in the next few months, we're going to be installing outdoor durability tests. So flat panel tests, which sort of mimic a cladding application. It's a north-facing frame at 45 degrees, and the samples sit on these rails that are made of untreated radiated pine. So the idea is that these rails will get fungi living in them, they'll start to decay, and that will make sure that decay fungi are introduced to all of the samples we're testing and potentially make them rot faster. And then we have decking tests where, again, you can see the deck is very, very close to the ground. It's got grass growing through it. It's quite a severe test, so you're expecting to have a shorter service life or shorter life than you would have for a standard deck, so you can get some results sooner. And there's a big team of people who are working on this with me, so I would like to thank them all for their contributions, and thank you for listening.